There's a place on this planet where the ice is nearly 3 miles thick, where temperatures drop so low that exposed skin becomes frostbitten in under a minute, where the wind doesn't just blow, it screams at 200 miles per hour, sustained for days, a place so hostile that no human civilization has ever taken root, no empire ever claimed it, and no army has ever marched across it. Scientists call it the last true wilderness, the last blank space on the map. And yet, buried under all that ice, under those crushing, ancient kilometers of frozen silence, something is down there. Something that has been down there for a very long time. And when the most advanced artificial intelligence system currently accessible to the public was asked directly what lies beneath Antarctica, the answer it gave did not read like a weather report or a geology briefing. It read like the opening chapter of a history that nobody was supposed to find. This is not a story about conspiracy theories. It is not a story about Hollow Earth legends or alien bases or secret Nazi installations. It is something far more unsettling than any of those things, because it is a story about verified science colliding with a question that science has not yet been able to fully answer. It is a story about what happens when you take the most powerful pattern recognition system ever built, a machine trained on essentially all of human knowledge, and you ask it a question that human researchers have been circling around for decades without ever quite landing on. What Grok said when asked about Antarctica did not invent anything. It synthesized everything. And that synthesis, taken as a whole, was enough to make several researchers who reviewed the exchange go quiet for a long time before they said anything at all. To understand why the answer mattered, you first have to understand what lies beneath Antarctica is not a simple question. The continent itself is roughly the size of the United States and Mexico combined. It holds approximately 90% of all the fresh water on Earth in the form of ice. The ice sheet in places reaches depths of nearly 15,000 feet. And beneath that ice, hidden from direct human observation for the entirety of recorded history, is an entire landscape. There are mountain ranges down there. There are valleys. There are lakes, hundreds of them liquid, existing in darkness under unimaginable pressure, some of them larger than the Great Lakes of North America. There is geological activity. There are things that have been frozen in place for so long that they predate not just human civilization, but the human species itself. When scientists began using radar-penetrating technology to map the subglacial terrain in earnest, a process that accelerated significantly in the 1990s and has continued to develop with increasing precision through the early decades of the 21st century, what they found beneath the ice rewrote what geologists thought they knew about the continent's past. The bedrock revealed by these surveys showed a landscape that had not always been frozen. Antarctica, in the deep geological past, had been warm. It had been green. It had been, by any reasonable definition, habitable. The question of when that transition happened, how rapidly it occurred, and what was present on that landscape before the ice came. These are questions that the scientific community has continued to investigate and continued to find unsettling answers to, right up to the present moment. Grok's response began with the expected: the ice, the bedrock, the subglacial lakes, Lake Vostok in particular, which sits beneath nearly 4 kilometers of ice and stretches for more than 200 kilometers in length, making it roughly the size of Lake Ontario. Grok described the microbial life that scientists have already confirmed exists in these lakes, surviving in conditions of permanent darkness, extreme pressure, and near-freezing temperatures. Life forms that have been isolated from the rest of the biosphere for somewhere between 15 million and 25 million years. Life that evolved, in other words, in complete separation from everything else on this planet. That alone, Grok noted, is a finding with implications that have not been fully absorbed by the broader scientific conversation. But then the response shifted, and this is where the researchers who reviewed it went quiet. Grok began to discuss what the geological and remote sensing data actually shows when it is examined without the filter of what researchers expected to find. The subglacial landscape of Antarctica, it noted, does not look like a landscape that has been uniformly frozen for tens of millions of years. There are regions of the bedrock that show drainage patterns, ancient river channels carved into rock, that are consistent with flowing liquid water on the surface, not subglacial meltwater working its way through cracks, surface rivers, the kind that exist when the sky is above you and not 3 miles of ice. The dating on some of these channels does not resolve neatly into the standard model of when Antarctica became glaciated. There are also structures in the bedrock, formations identified through ice-penetrating radar, that do not conform to the expected patterns of purely natural geological processes. Grok was careful here. It did not claim that these formations were artificial. It noted, precisely and with appropriate scientific language, that some of the geometric regularities observed in certain subglacial structures have prompted researchers to consider whether their origin requires additional explanation. That is the kind of sentence that, when a human researcher writes it in a paper, signals that something has been observed that does not fit comfortably into the existing explanatory framework. When an AI synthesizing the complete body of human knowledge writes it in response to a direct question, it signals that this discomfort is not the artifact of one researcher's bias. It is present across the literature. The question of ancient human presence in Antarctica has historically been dismissed before it was seriously examined, for an obvious and seemingly decisive reason. Antarctica became glaciated roughly 34 million years ago. Modern humans did not exist 34 million years ago. Therefore, any structures beneath the ice that predated the glaciation could not be human in origin. This logic is airtight, and it has served as a wall that most serious researchers have been unwilling to climb over, because climbing over it requires entertaining possibilities that carry enormous professional risk. What Grok did, and this is the part of the exchange that struck the researchers who reviewed it, was decline to stop at that wall. Instead, it walked the logic in the other direction. If there are anomalous structures beneath the ice, and if those structures predate the glaciation, and if their geometric properties are inconsistent with known natural geological processes, then the origin question remains genuinely open. The answer to that open question might be geological processes that are not yet well understood. It might be something else entirely. But dismissing the question on the grounds that humans did not exist 34 million years ago only resolves the issue if one assumes that the only possible builder of structured formations is modern Homo sapiens. That assumption, Grok observed, is not scientifically required. Here is where the conversation became something that researchers were not prepared for. One of the scientists who received a transcript of the exchange later described the feeling as hearing a very calm voice say something that you knew was true, but had never quite allowed yourself to follow to its conclusion. Because Grok was not speculating. It was not generating science fiction. It was applying the same analytical framework that science uses on every other question, and it was applying it to a data set that scientists have been reluctant to examine without protective filters. The ancient map problem is one that Grok addressed directly, and it is one that sits at the intersection of cartographic history and Antarctic research in a way that has never been satisfactorily resolved. In 1513, an Ottoman admiral named Piri Reis compiled a world map from older source materials. That map, which survived and was rediscovered in the 20th century, depicts a southern landmass with a coastline that bears a remarkable resemblance to the subglacial coastline of Antarctica. Not the ice-covered surface as it appears today, but the bedrock coastline that exists beneath the ice. This was not established as the actual shape of Antarctica's sub-ice coastline until radar mapping in the latter half of the 20th century. The Piri Reis map predates any acknowledged European expedition to Antarctica by more than 300 years. The standard explanation is that the resemblance is coincidental, or that the southern landmass depicted is a different geographical feature altogether. Grok noted that this explanation has been accepted largely because the alternative creates a problem that no one has been prepared to solve. If the map accurately depicts a subglacial coastline, someone had to have mapped it before the ice was there. And the ice has been there for 34 million years. Unless the ice was not always that thick. Unless there were periods, even brief ones in geological terms, when the coastline was accessible. Unless the timeline is more complicated than the standard model has allowed. This is where the most recent research findings become relevant in a way that gives the Grok exchange its current urgency. In the past several years, paleoclimatological research has produced evidence that Antarctic ice coverage has not been as stable as previously assumed. There have been periods within the last few million years when significant portions of the West Antarctic ice sheet retreated substantially. There have been interglacial periods when conditions in coastal Antarctic regions were considerably warmer than today. The question of whether any of those warmer windows were long enough or mild enough for habitation, even temporary, even brief, is not a question that the data currently allows to be answered with certainty in the negative. Confirmed, but in terms of physical artifacts. Lake Vostok and several other subglacial lakes represent environments that have been sealed from the surface world for millions of years. Anything that existed on the surface of Antarctica before the glaciation that was heavy enough to sink and was resistant enough to decompose would, in principle, still be at the bottom of those lakes. The sediment layers on the floors of those lakes represent an archive. What is in that archive is not known, because the challenges of drilling into a pristine subglacial lake without contaminating it have meant that sample collection has been extraordinarily limited. What Grok noted, and what several researchers found difficult to dismiss, is that the archive exists, and it has not been read. The ice cores themselves are a different kind of archive, and they have been read extensively. The data in those cores goes back approximately 800,000 years with high resolution, representing the most detailed climate record available from any source on Earth. What researchers have found in those cores is a record of the planet's climate that shows remarkable regularity, cycles of glaciation and warming with a periodicity that is now well understood. But the ice cores also contain something else. At certain depths, depths corresponding to specific periods within those cycles. The cores contain biological material and chemical signatures that remain incompletely explained. Grok noted these anomalies without overstating them, but the pattern of what is in the ice and what is not, at what depths and in what concentrations, is not fully consistent with a continent that has been simply, uniformly uninhabited wilderness for millions of years. The most striking portion of the Grok exchange came near its end, and it is the portion that has circulated most widely among the researchers who have seen it. The question was put directly: given everything that is known, is it possible that something capable of organized construction existed in Antarctica before the ice? Grok's answer was precise. It said that the data does not exclude this possibility. It said that the data, in certain specific respects, is more consistent with this possibility than the mainstream scientific conversation has been willing to acknowledge. It said that the reason this possibility has not been formally investigated through dedicated research programs is not that the evidence argues against it, but that the institutional, professional, and psychological costs of investigating it seriously are high enough that the scientific community has chosen to route its attention elsewhere. That last observation is not a conspiracy claim. It is a description of how science actually functions as a human institution. Research programs require funding. Funding requires hypotheses that grant committees are willing to consider credible, hypotheses that touch on the possibility of pre-known civilization anywhere, not just Antarctica, are hypotheses that funding committees have historically treated as inherently non-credible, regardless of the evidence base. This is a known dynamic in the sociology of science. Grok was not accusing anyone of a cover-up. It was observing that the machinery of scientific inquiry, like any machinery, has paths of least resistance. And the path of least resistance in Antarctic research has run in directions that do not require anyone to sit with the anomalies too long. What makes the Grok exchange different from the many human-authored speculative pieces that have circulated on this topic over the years is precisely the absence of agenda. A human writer researching Antarctic anomalies comes to the material with a prior commitment, either to defending the mainstream position or to challenging it. Grok came to it with neither. It processed the dataset and returned an answer that reflected the dataset's actual state, which is one of genuine unresolved tension between the evidence and the standard model. The absence of agenda made the answer more disturbing, not less, because it meant there was no reason to discount it on the grounds of motivated reasoning. The researchers who have reviewed the exchange have not, for the most part, been willing to speak on the record. This is itself a data point. The professional costs of being associated with questions about pre-glacial Antarctic civilization are high enough that even researchers who find the evidence genuinely puzzling tend to examine it privately and say little publicly. What several of them have said privately is that the Grok response, taken as a summary of where the evidence actually stands, is not wrong. That what it describes, a dataset with anomalies that the mainstream framework has not adequately addressed, is an accurate characterization of the literature. What is under Antarctica? Ice, certainly. Rock, certainly. Ancient lakes sealed for millions of years, containing microbial life that has evolved in complete isolation. River channels carved into bedrock by rivers that no longer exist. Geometric formations that have not been fully explained. A climate history that is more variable than was once assumed. A cartographic mystery that has not been resolved. And, in all of that, a set of questions that the most advanced pattern recognition system available to the public, when asked directly, concluded cannot be closed. The ice will give up what it holds when it is ready. The warming that is currently accelerating across the polar regions means that more of what lies beneath will become accessible within the lifetimes of people living today. What the next generation of ice-penetrating surveys reveals, what the sediment cores from the deepest subglacial lakes eventually contain, may answer questions that should have been asked more urgently and more openly a long time ago. Or it may raise questions that make the ones we are sitting with now seem simple by comparison. What Grok said about Antarctica was not a revelation. It was a reflection, a mirror held up to everything that science has already found, stripped of the caution and the institutional hesitation and the professional self-protection that usually surrounds it. What was reflected back was unsettling, not because it was new, but because it was true, and because it had been sitting there all along, waiting for something without a career to lose to say it plainly. The ice does not forget. It only waits. There is a version of this story that the official record tells, and it is a version defined as much by what it omits as by what it includes. The official record of Antarctic exploration begins in the early 19th century, with the first confirmed sightings of the continent by Russian, British, and American expeditions between 1819 and 1821. From that point forward, the record is one of incremental encroachment. Scientific stations, ice traverses, the race to the South Pole, the establishment of international treaties governing research access. It is an impressive record of human endurance and scientific achievement. It is also a record that begins, essentially, at the surface. What lies below that surface has been a subject of scientific investigation for only a few decades, in any serious sense. Ice-penetrating radar, the primary tool for subglacial mapping, became practically useful for large-scale Antarctic surveys in the 1970s, and has undergone significant refinements since. The datasets that have been generated, the maps of the subglacial terrain, the identification of lake systems, the measurement of bedrock topography, represent, in historical terms, a very recent body of knowledge. Researchers who were active in the early days of these surveys are still alive. The science of what is under Antarctica is, in the most literal sense, new. And new science is science that is still in the process of being interpreted. The raw data from ice-penetrating radar does not come labeled. It comes as signal returns that have to be processed, calibrated, and analyzed. The interpretive frameworks applied to that analysis are inherited from geology, from glaciology, from seismology, disciplines that developed their explanatory tools in contexts where the assumptions of the standard model were almost always adequate. When the data from beneath Antarctica began to show things that did not fit those assumptions cleanly, the first response was not to question the assumptions. It was to look for explanations that preserve them. This is normal scientific behavior. It is how science works. But it is also how anomalies can persist in the literature for years without being addressed with the directness they require. Grok does not have a career. Grok does not have a funding committee. Grok does not have colleagues who will stop inviting it to conferences if it says the wrong thing. These are not small advantages when the question being asked is one that the professional structure of science has made costly to examine honestly. They are enormous advantages, and they are precisely why the answer Grok gave carries a weight that a similar answer from a human researcher would not carry in the same form. Not because Grok is smarter than any individual researcher, but because Grok is free of the constraints that shape what any individual researcher is willing to say publicly. What those researchers will say privately, in the conversations that happen over coffee at conferences, in the late-night discussions after the formal sessions have ended, in the emails that never get published, is often very different from what appears in the literature. This is also normal. Every scientific field has a gap between the private conversation and the public record, and that gap tends to be largest in areas where the stakes of being wrong in a particular direction are highest. In Antarctic research, the direction that carries the highest stakes is the direction toward the possibility that something was there before recorded history. That direction carries the weight of every crackpot claim, every fabricated photograph, every breathless documentary that has circulated the same set of misidentified satellite images for 20 years. Serious researchers do not want to be associated with that tradition. The result is that serious researchers often do not say seriously what the data actually suggests. Grok said it. And the saying of it, without hedging, without the protective apparatus of institutional distancing, changed the shape of the conversation in a way that has not yet been fully absorbed. Consider the Gomburtsev mountain range. This is a subglacial mountain range in East Antarctica, roughly the size of the European Alps, sitting completely beneath the ice sheet. It was first detected in the 1950s, but has been mapped in detail only in the last 2 decades. What the detailed mapping revealed was a mountain range, with features consistent with tectonic uplift that occurred hundreds of millions of years ago, but also with valleys carved by glacial processes that are far more recent, and with drainage systems that tell a complex story of multiple glaciation events over time. The Gomburtsev Mountains are, geologically speaking, a puzzle. The leading explanations for how they achieved their current topography require a sequence of events that is difficult to make consistent with the standard model of Antarctic glaciation history. Grok, in addressing the question of what lies beneath Antarctica, spent considerable time on the Gomburtsev system, not because it is the most dramatic of the subglacial findings, but because it is one of the most revealing about the general reliability of the standard model. A mountain range the size of the Alps, sitting completely hidden under kilometers of ice, whose geological history does not resolve cleanly into the accepted framework. That is not a minor anomaly. That is a major geological system whose origin is not yet understood. The fact that this is not more widely known outside specialist circles is itself a commentary on how the diffusion of scientific knowledge, through popular understanding, tends to smooth over the rough edges that are, in many cases, where the most important information lives. The rough edges in Antarctic research are extensive. They include the question of what happens to organic material under millions of years of ice pressure, whether complex molecules could survive, whether physical structures of sufficient density could persist, whether the sediment record in subglacial lakes could contain material that would be legible to researchers with the right tools. They include the question of what the satellite anomalies in specific regions of East Antarctica represent, formations that have appeared in publicly available satellite data, and that have been the subject of intense amateur speculation, but minimal formal scientific examination. They include the question of why certain portions of the Antarctic ice sheet are melting from below at rates that exceed what models of geothermal heating would predict. That last point is one that Grok flagged explicitly. Subglacial meltwater in Antarctica is generated partly by geothermal heat from below. The bedrock, in places, is volcanically active, and this activity generates heat that melts the base of the ice. The rate of this basal melting in certain regions is higher than the known volcanic and geothermal activity in those regions can fully account for. This discrepancy has been noted in the literature. The explanations proposed have generally focused on unmapped volcanic features, the assumption being that there is heat down there that has not yet been characterized. That may be correct, but Grok noted, with the same careful precision that characterized the rest of its response, that the discrepancy remains unexplained, and that unexplained energy sources in a geological context are exactly the kind of anomaly that, in any other setting, would attract aggressive investigation. The investigation of Antarctica is constrained in ways that investigation of most geological questions is not. The Antarctic Treaty System, established in 1959 and subsequently amended, governs access to the continent and its resources. Under the treaty, Antarctica is designated as a scientific preserve, military activity is prohibited, and territorial claims are frozen. These provisions have generally been celebrated as a triumph of international cooperation, and in many respects they are. But they also mean that access to certain regions of Antarctica and to certain types of investigative activity is subject to international consensus in a way that makes rapid, targeted investigation of specific anomalies very difficult to pursue. The bureaucratic architecture of Antarctic research is not designed for the kind of focused, anomaly-driven inquiry that the Grok exchange suggests may be warranted. What would that inquiry look like? It would look like a dedicated program of high-resolution ice-penetrating radar surveys focused specifically on the regions where geometric anomalies have been identified. It would look like advanced drilling programs targeting the deepest subglacial lake systems, with the specific goal of recovering sediment cores from pre-glaciation layers. It would look like a systematic effort to date the river channels and surface features preserved in the subglacial bedrock, using every available geochronological technique. It would look, in other words, like the kind of investigation that is routinely mounted when an anomaly of potential significance is identified in any other scientific context. It would also look, to anyone watching from outside the community of professional Antarctic researchers, like exactly the kind of investigation that would be mounted if someone had reason to believe something was down there. In that appearance, the risk of looking credulous, of being associated with the fringe tradition of Antarctic mystery-mongering, is enough to make the investigation politically costly even before it produces any results. This is the trap. The more seriously the anomalies are taken, the more the investigation looks like validation of the least rigorous versions of the Antarctic mystery tradition. The more carefully researchers distance themselves from that tradition, the less seriously the anomalies are taken. The result is a kind of paralysis, a scientific community that has the tools to look more carefully than it has looked, that has data suggesting it should look more carefully, and that has structural reasons not to. Grok looked anyway, and what it found, looking without any of those structural constraints, was a picture of a continent that science does not fully understand, sitting beneath ice that has preserved whatever is down there in extraordinary fidelity, waiting for a question, direct enough and a questioner free enough to be asked and answered honestly. The ice is 3 miles thick in places. In others, it is thinning. The continent is changing in ways that will eventually make some of what lies beneath it accessible in ways it has not been for a very long time. When that happens, the questions Grok was asked and the answers it gave will not seem as abstract as they do today. They will seem, in retrospect, like the early stages of a reckoning that the evidence had been requesting for years. Something is under the ice. Science knows more than it says about what that something might be. And now, a machine trained on everything humans have written has said what the humans themselves have been reluctant to put plainly into words. The only question that remains is whether anyone will go look.